All right, so today we're going to work on the next page in our right triangle book, and we're going to talk about special right triangles. There are two types of special right triangles, and they're special because their side lengths have an automatic relationship. We know exactly how long one side is going to be if we know the length of another side in these two guys, okay? As you see here, the two special right triangles that we have are 45, 45, 90 and 30, 60, 90. Okay? And so we need to get these in our book. So about the top third of your page needs to be dedicated to getting this in. Okay? Now, in a 45, 45, 90 triangle, so this guy right here is your 45, 45, 90. And what the 45, 45, 90 refers to are the angle measures inside of there. Okay, so a 90-degree angle to make it a right triangle. And then if the two acute angles are 45 degrees, that creates this special 45, 45, 90 triangle. Okay? Now, a couple of things we need to understand. In a 45, 45, 90 triangle, that takes this right triangle and it also makes it isosceles. Remember that in an isosceles triangle, the base angles are congruent. And then we had the converse of the isosceles triangle theorem, which says if two angles are congruent in a triangle, then their opposite sides are congruent and therefore makes it an isosceles triangle. So this is considered an isosceles triangle. So a lot of ways we can determine if we're looking at a 45, 45, 90 triangle. One, if we know that these two legs are congruent, then we know it's going to be a 45, 45, 90 triangle. If I know that the two angles are congruent by, say, just some arcs, then I know it's a 45, 45, 90 triangle. And of course, if we have the angle measures, 45, 45, and 90, then it's going to be a 45, 45, 90 triangle. Now, if we know that this side length, that this leg is, say, 1 inch, okay, then what we will automatically know is that obviously the other leg is going to be the same. The leg is going to be equal to the leg because it's an isosceles triangle. And so we get our first sort of equation here. So the leg is going to equal the leg. Okay? Now, what is also true, and you can kind of do this, if you know that each leg is 1 inch, then you can do Pythagorean theorem and verify this. But if the legs are 1 inch, then the hypotenuse is going to automatically be the square root of 2. And that's because the hypotenuse is always square root of 2 times the leg. It's always the square root of 2 times longer than the leg. So if I want to find the length of the hypotenuse, and I know the length of a leg in a 45, 45, 90 triangle, then I can just take the leg and multiply it by radical 2. Okay, so that's the relationship. And I do this picture for any of you that are sort of more visual and you have and you're more artistic and you kind of like to look at a picture. I like equations, right? So what I know from this is that the leg is going to equal the leg, which is duh. And then I can write an equation that says that the hypotenuse is equal to the leg times radical 2. And when I determine a 45, 45, 90 triangle, I'm going to write these two equations down and then fill in lengths or variables or whatever I need to. Okay? So that's your 45, 45, 90 triangle. The same is kind of true about a 30, 60, 90 triangle, right? So it's a 90-degree angle, it's a right triangle. 30 degrees, 60 degrees are the other two angle measures. Now, in a 30, 60, 90 right triangle, one leg is going to be longer than the other leg. And so you're going to have to remember which leg is going to be the longer leg. Well, last semester we had a theorem, a triangle inequality theorem, that says that the bigger the angle is in a triangle, the longer the opposite side is. So the fact that this angle 60 is bigger than this angle 30, that means its opposite side is going to be longer than this guy's opposite side. So what does that mean for us? It means that the long leg is always opposite or always across from the 60-degree angle, which is why I have LL written down here. This side right here is going to be the long leg because it's across from the 60-degree angle. This guy right here is going to be the short leg because it's across from the 30-degree angle, and that will always be true. Okay? Now, that being said, the relationship amongst the sides is always based off of the short leg. Always based off of the short leg. So in a 30, 60, 90 triangle, it's really important that we find the length of the short leg. Okay? So if the short leg were, say, 1 inch, kind of like what we did over here for the 45, 45, 90, then what I will know automatically is that the hypotenuse is 2 inches, because the hypotenuse is always twice as long as the short leg. The hypotenuse is always 2 times the length of the short leg. The long leg, if the short leg is 1 inch, the long leg will be the square root of 3, because the long leg is always the square root of 3 times longer than the short leg. So if this short leg were 1 inch, that would make this hypotenuse 2 times 1, or 2 inches, and the long leg radical 3 times 1, or radical 3 inches. Okay? And so that's what you see here in this diagram. Again, for you artistic folks, the short leg is 1. That means the hypotenuse is 2. That means the long leg is radical 3. This is the long leg because it's across from a 60-degree angle. This is the short leg because it's across from a 30-degree angle. Okay? Now, for you algebra people that like equations like me, then what I do is in a 30, 60, 90 triangle, I write out 2 equations, fill in what I know, and then solve for any variables that I have. Okay? I know that the hypotenuse is 2 times the short leg. So I write that equation out. Hypotenuse equals 2 times short leg. I also know that the long leg is the square root of 3 times the short leg. So I write that equation out. Long leg equals radical 3 times the short leg. Okay? And so I'm going to keep referring to these equations. And that's all there is to special right triangles. There's only 2 of them, and those are the side relationships. And so these side relationships are just going to let us know the side lengths. Okay? The angles we use to identify the triangle, these equations we use to find the side lengths. Okay? So let's try to use them. Okay, so you've got some examples here. Maybe don't worry about this one just yet. These 3 just yet. Okay, let's focus on this first one. So we're going to find missing sides. All right? This first triangle, get that drawn in. And so hopefully you recognize that this guy is a 45, 45, 90 triangle. Okay? And I know that because this is an isosceles right triangle. All right? In a 45, 45, 90, I know that the leg equals the leg, and the hypotenuse is the square root of 2 times the leg. To find the other side lengths, easy enough. This leg is 6. That means this leg is 6. So this guy is going to be 6. We can make variables here. That makes more sense. So this is going to be x and this is going to be y. So I put in x for one leg, 6 for the other leg, x is 6. I put in y for the hypotenuse. The leg is 6. So now I get 6 times the square root of 2. So y is 6 times the square root of 2. And it's that simple. Okay, excuse me there. And that's all there is to it. All we need now is just one side length. If we have one side length and it's a special right triangle, we can find the other 2. No problem. No Pythagorean theorem. No weird proportions. Just use these relationships. Okay? Now, same can be said in a 30, 60, 90 triangle, which is what this next guy is. He is a 30, 60, 90. And you see that because that 30-degree angle is there. That means that this side is the short leg, this side is the long leg, and obviously this guy is the hypotenuse. He never moves. This is always the hypotenuse crossing the right angle. Okay? So, I have a 36, 90 triangle. I have a couple of equations to write down. I know that the long leg is equal to the square root of 3 times the short leg. And I know that the hypotenuse is equal to 2 times the short leg. Well, in this guy, this side right here is the hypotenuse. So I put in 8 for the hypotenuse. Let this be x and this be y. So the short leg is x. I can solve that, divide by 2, and x is 4. So now, this is 4. If the short leg is 4, then I can plug that in here and find the long leg, which is y. By taking radical 3 times 4, and so y is going to be 4 radical 3. And that's it. That's all there is to it. Write down the equations, plug in what you know, and go from there. All right? So I'll give you a second on this next example here. Okay, stop the video, try to find, let's make this x, this y, try to find x and y real quick. And then start it back up and see how you do. Okay, let's get it done. This is a 45, 45, 90 triangle. Okay, so that means I'm going to use these two equations. Leg equals leg, and hypotenuse equals radical 2 times the leg, right? So this guy is a leg. This guy is a leg. So my first equation turns into x equals 9 radical 2. Good. Done. Found x. This is the hypotenuse. So I'm going to plug that in for hypotenuse up here. So y equals radical 2 times the leg, which is 9 radical 2. Now remember, when you're multiplying radicals, we multiply the numbers on the outside and then multiply numbers on the inside. This becomes 9 times the square root of 4. Square root of 4 is 2. So we get 9 times 2, which is 18. And that's y. And we're done. Okay? Makes sense? I do hope so. Okay? Same thing for this next example. I'm going to get rid of this. You can always back the video up if you want to see this again. So you have room to work this guy out. So try this example, the 30, 60, 90. See what you come up with. Stop the video. Start it back up again when you're done. See how you do. All right. So like we said, this is a 30, 60, 90 triangle. So we need the 30, 60, 90 equations. The 30, 60, 90 equations look like what? Long leg equals radical 3 times the short leg. And hypotenuse equals 2 times the short leg. Let this be x and this be y. Sorry, I should let you know that at the beginning. Okay? All right. X is the short leg. It's across from the 30-degree angle. So I'm going to let this be x. Let this be x. Okay? Y is the hypotenuse. So I'm going to plug in y here. So I get y equals 2x, and I cannot solve that equation. The long leg is 18. So I get 18 equals x times radical 3. Now, I can solve that equation simply by dividing by the square root of 3. So now, I'm going to bring it up here. X equals 18 over the square root of 3. Remember, we cannot leave a radical in the denominator, so I'm going to multiply the numerator by radical 3 and the denominator by radical 3. I can do that because I'm multiplying by 1 and I'm not really changing the fraction. Okay? I'm just going to change the way it looks. 18 times radical 3 is just 18 radical 3. Square root of 3 times square root of 3 is the square root of 9. Square root of 9 is 3. So now the square root is gone. Since 18 and 3 here on the outside, I can divide that out. And so x simply becomes 6 square root of 3. Okay? Since x is 6 square root of 3, I can plug that in down to this equation. Multiply 2 times square root of 3, which I'm starting to hide again. That's all right. 2 times 6 is 12. And so y equals 12 square root of 3. Okay, done there. Hopefully that made enough sense. Okay, take those examples. You have homework out in Canvas. Give that a shot. We'll talk about it next time.